Morning, my dear kids. In today's class, in the electromagnetic induction chapter, we are going to discuss some of the different types of numericals in motional EMF. Almost all the theoretical ideas is what I discussed. We'll go for some applications, like in various situations, how that motional EMF concept can be applied. So basically, I think you can divide this into 4 parts: Faraday's law, Lenz's law, motional EMF, and rotational motional EMF. The rest all what all we discussed. Everything will be the application of all these 4 topics one by one. So we'll explore all the possible numericals in available time. So I'll try to discuss maximum number of different ideas here. Let me start the class. I'll go for a little bit lighter one. This will be better. So let there be a ring. The same yesterday's discussion, and we are going to have a rod. Instead of this, I'll bring a capacitor. There's no resistance for any of the things. So there's a rod OP, uniform angle, the same condition. So this rod is having mass M, OP equal to L. So conducting ring, iron ring, I'll write it. Iron ring. Of negligible resistance. So I'm going to rotate this with a constant torque. A constant torque, initially it is a constant torque will act at T equal 0. Then I'm asking you to get the expression for current through the capacitor at any time. The rod OP is rotated. It's a constant torque, tau naught. Find the current through the capacitor at any time T. At T equals 0, the rod is at rest. Okay, no. I'm bringing a constant torque. We know this B bar. So I think you have to directly come to the yesterday's application, what all we have discussed. You can't derive all the things in exam especially. So therefore, so what I suggest is like a rough diagram, at least like what are the various situations. I'll go for rough diagram rather than how this rotating rod will be like a cell. So B bar. So this end, it will be like this. The capacitor. No, this will have EMF induced, a constant torque will act. We know that induced current has to flow in this direction. Then there's a B bar current. So there'll be induced torque will act in this direction. But what is the condition? It is being put with a constant torque that one. So therefore, this will have an angular velocity omega. So what is first EMF induced in the cell? B omega, or so in the rod B omega L square by 2. So then we want expression for current. Can we write I equal T by R? I think there's no resistance. Resistance of circuit is, I'll write it separately. It's 0. There is no resistance of circuit here. There's nothing called like a resistance is there. Okay, fine. This is, so what is it? We want expression for current. So there'll be in fact a flow of current in this direction. It will be off like this. How to calculate? So what is the first induced torque? I want directly the induced torque. Anybody? Induced torque B omega B square L to power of omega by 2R. Anything will you write here? I think we should not write the same old equation earlier what we had. Am I right? What to do now? Yes, some sort of capacitor there. So again, Q equal to CE. Little bit be alert. Things will change slightly here. What is equal to B omega L square by 2. Now this will differentiate dq by dt equal to CB L square by 2 d omega by dt. dq by dt equal to CB L square by 2. This will become alpha. This dq by dt is what? I. The I will take shape like this here. Then torque due to induced current should be equal to integral of any disturbance is there from my side? Can I continue? Okay, Yashovardhan. Okay, no, fine. How to calculate the torque due to? Okay, rough diagram. Rough diagram. So this is the current flowing in this. So we'll assume a small element. Then at a distance x, due to this, a magnetic field is into the plane. B bar. So this is dF. So the torque will be equal to dF into x. What is dF? Pi dx. So this I, let me keep as it is outside. So this will become x dx. 0 to L. So induced torque equal to Bi L square by 2. What is I? B L square by 2. Let me substitute I. CB L square by CB L square alpha by 2. So the induced torque is equal to B square L to power of 4 CB square L to power of 4 alpha by 4. You can't write that induced torque here. Okay, are you getting now? Because there is no resistor here, it's a capacitor is there. Okay, now what is the net torque acting on system? Tau naught minus tau I should be equal to ml square by 3 into alpha. What is tau I is equal to C B square L to power of 4 alpha by 4 equal to ml square by 3 into alpha. This is the expression for alpha. Now expression for current is asking. This should become equal to CB L square by 2 into alpha. Alpha value is what I'm going to substitute there. You can expect any of the very random arbitrary problem. So whenever capacitor comes, the current will be in terms of acceleration. There it was translated motion, linear acceleration. Here, angular acceleration. Okay, I think you need not to now any element can come here. Even I can bring a cell. I think you can manage very smartly. But the wherever maybe, if resistor is there, then what you're going to do? The current will be in terms of speed of the rod. Translated motion, rotating motion in terms of the angular speed of the rod. If capacitor is there, the current will be in terms of the acceleration, linear acceleration of the rod or angular acceleration of the rod. This is the key. These things is what students should write in your notes. This is what you made observation, no? This is what you learned. Such things is what should be entered in the notes. They are going to help you a lot in the final exam preparation. When you're revising, no, you need not to revise all the numerical, the core ideas. That is enough. Okay, note it down. We'll go for the next one more case of this. We'll take the same diagram. I'll bring a cell. And now this is as usual. Copper ring. Zero resistance, no resistance. This rod is having a resistance, so rod OP of mass M, length L, and resistance R is released from rest at t equal to 0. Find the I of t and omega of t. Rest all everything. There's no friction between the end of the rod and the ring. Carry on now. We have a cell here, no? What to do? The moment you switch on first the current through the cell, go back to translated motion with EMF. We have brought it, no? The similar thing here. There's a small motor. The small motor, what happen, will make the rod to move. First, what direction the current will flow? The current I will flow here. Then due to flow of current, B bar and the flow of current. So will there be any torque due to this? The current due to the cell? The current I will flow in this direction. Now get into this one. B bar this one. So now a force F will act here. Now this force acting will set up a torque on it and it starts rotating. Then EMF will be induced. Then there'll be induced current due to rotational motion EMF, but it will be in opposite sense. Try to analyze this. Okay, I'll again. So now first a current I will flow. This current I1, I'll write it. This current I1, I'll make the rod very small. In rod, I'll make it. So first in what direction current will flow? Current I1 will flow in this direction. We'll assume a small element. Then in what direction? It will experience a force here, B bar, BI1. So the force will act in this direction. Okay, this force will set up a torque. So because of torque, it will start accelerating. Then as it starts rotating, tell me what can happen? Now an EMF will be induced. Then due to the EMF induced, there'll be induced current. And now that induced current should be such that you should oppose the cause. What is the cause? I1 is the cause. To oppose that, I2 should flow. That's very much justified. So which end will be at positive? So this end will be positive, this will be negative. So that the induced current should flow in this direction. So the resultant current will be in this direction only. So there will torque due to induced current. I'll write it tau E. So then, sir, like this rotating rod, will it behave like a cell? Yes, in fact, it's behave like a cell. I'm just giving various diagrams so that you can get an idea. So this is EMF induced. So the resultant current will still flow in this direction. What is I? I1 minus I2. So the net torque acting on system will be in this direction. Alpha, I'll write it home. I can't dump so many things here. This is DF1, you will write it. So how DF2? DF2 will act opposite direction. So many things. DF2 is DF2 into X will be retarding torque. DF1X will be the exerting torque produced by the cell. So resultant current. So what is I2? Now I2 should flow. I2. So this cell will generate an I2 that one. So what is I2? I2 should be equal to E by R. Will bring resistance. Okay, rod is having resistance. No? Resistance also. Let me introduce here R. So this will become B omega L square by 2R. This you know. What about I1? I1 should be just E by R. The resultant current should be equal to I1 minus I2. So therefore, now what we can write? I naught alpha should be equal to net induced torque. How much it should be? B square L to power of 4 I by 2R. Shall I write directly? I don't want to simplify. Already I told you, you have to remember this one. ML square by 3 into alpha. Okay, this will become B square L to power of 4 to R. What is I? E by R, B omega L square by 2R. Okay, I think so. Just wait. Yes, sound. Okay, I is equal to we have to bring the induced torque expression for in terms of that one. This is about the resultant current. So how to induce torque? Again, the same thing. The resultant, again, the induced torque. I'll show last once so that. Why I1 greater than I2? I think common sense. Initially, what is the state of the rod? Rod is at rest now. The EMF E will increase with the time. The rod was at rest. So therefore, I1 will be greater than I2. It has to be. Why means then common sense. There's no physics concept. What was initially? I wrote something. Rod is at rest. When you switch on first current, I1 will flow. Because of I1, it starts moving. Then it will start accelerating from rest. If a body accelerates from rest, angular velocity will increase with the time. So as the angular velocity increases, EMF, small e will increase. Okay, we have to analyze a lot there. So d tau is equal to again df into x. This is di dx. There's a one last time is what I'm showing. This is a net torque acting on this one. So this should be equal to how much? I naught alpha bi L square by 2. Okay, now we'll substitute all the things. ml square by 3 alpha bl square by 2. What is I? I is what? I substituted there. Can you solve this after from here? From here, can you work out? Because I'm asking find the I of t and omega t. So one m will cancel out. So this will become 3 will be there. So d omega by dt is equal to 3b by 2m er bl square omega by 2r. Solve for d omega by dt, solve for omega. It's the same thing what we had in transient motion, the equation is going to come. This if I further substitute. Three BE 2MR equal to 3B square L square omega by 4MR. Now we are going to integrate this. So this is say some A minus B omega. At t equals 0, it was at rest at any time t, this one. So this will become omega equal to I'm just writing all things directly. It will increase exponentially. We know this, that it will happen. You compare with the translatory motion. This value of omega substitute there, you get expression for current. So if you look at the angular velocity of the rod, it is going to be like this. What are A and B? I'm indicating there. We don't have much discussion in the books of these kind of numericals. Just I shown one capacitor and this cell also for body rotating in a rotational EMF can be introduced. So how to get the expression for current? This value of omega we are going to substitute here. Let me write that also. This will become BL square A by okay, just make all complete observation. We'll go for the next topic discussion. I think all these are a little bit, you should understand the methodology. It's not like something like a translative motion, rotative motion. Almost the ideas are same. The energy conversions parameter will be same. But in applications, we do prefer rotation motion EMF only. Because here the size of equipment will be very small compared to translative motion. Let's go forward. And then now I'll pick up small numericals. May not be like this lengthy, but these are very important. I really feel a student must have a very good understanding of all these numericals. These are very popular objective based questions for mains or advanced, anything it can come. Okay, radius smaller, will write it. It contains one conducting spoke. So this iron ring. Copper, and it's having a pure rolling. And there's a uniform magnetic field is present everywhere. Some other symbols, let me present you. It's having a pure rolling, and there's a conducting spoke of length radius r is present at this instant. Now, potential difference VOA is being asked. You have to find out potential difference VO. I'll give the small description of question. A conducting ring of radius r with a conducting spoke is in pure rolling on a horizontal surface in a uniform magnetic field. In an uniform magnetic field as shown. Find potential difference VO. Find the VO minus VA. So what I'm giving, it's having pure rolling. Pure rolling, it's understood that the angular velocity, what all it will have, that omega we can write as V by R. I need not to separately mention again omega. How you manage questions of this kind. Sir, I'm very good in rotation mechanics. Okay, apply. So if you go for rotation mechanics, so what is this? All points on the rod will have translative as well as rotative motion. Am I right? Yes. So now what we'll do is like I'll assume a small element. Then what is the velocity of this point will be V. What about velocity of this point? 0. What about velocity of other points will be V minus R omega. And the radius will change V minus X omega. So the different points, say you must have a strategy. I'll directly write one formula, sir. Please give one formula. Not possible. A student must have really analyze first one. Later on comes the problem solving. So here this is having velocity V. This is 0, no? Pure rolling. Velocity of end should be 0. Then what about velocity of any point P? V. Let me take X. Let me take this is Y. This will have Y omega. What is velocity of point P? V minus Y omega. Then let's assume a small element, then integrate. Pure rolling is there. So what you can write as omega s further. Omega s V by R. Nothing wrong. You assume a small element, then integrate. Do think. I'm leaving mathematics part to students. That's all, no? Motional EMF concept. I know in pure rolling, like if since it's a pure rolling, then all points will have same angular velocity about point A. I think the entire ring I'll take this. Instead of making that, I'll come to the instantaneous center. About instant center, all points will have only rotatory motion. And what is omega? Should be equal to V by R. So it is now the rod is asking potential difference across the rod OE. Find the potential difference VOA is asking. So now what is the like a motional EMF concept? VEOA should be equal to V omega R square by 2. Shall we go for like this? Potential difference across the rod OA, the rod is rotating about this particular point with an angular velocity omega. Now what is omega? Omega is V by R. Anybody wants to object, or sir, how come you can write diagram like this? All points will have same angles to omega. So B omega emitting. What is omega? Omega will be further V by R. Which end will be positive? This is what like potential difference VOA is asking. It's not that the EMF induced across the rod. Okay, due to its rotating motion. What about EMF induced across the ring? There are two things are there. No? Actually, this is connected to the rod is connected to the ring at this particular point, and it is spinning this one here. I'm just asking potential difference across it. Will there be any potential difference between point 2 and the ring also? It has to be no. So separately for the ring, this is for rod. For ring, what we have to discuss. Anybody for the ring, what we can write? This is for rod OA. This one for the ring we have to. Actually, can you remember? Here also the ring, same thing we can put it. But what is the length of the ring? The length of the ring is how much? Will become 2R, no? The effective length will become 2R. Then we'll calculate the total EMF induced across the ring. I want only EMF between these 2 points. A, O. Okay, let me call this is C. Or D will call it. But I want only EMF induced for the effective length of the ring here. So this will become 2R. Now bring your ideas. So what is EMF induced for only that part, not for the total one. The limit should be from 0 to R only. So the what is EMF induced across the ring? It will be AO potential difference, no, which will be at higher potential B bar. OA is asking from O to A, this one. OA, this is D. But again, the D is what will come into picture here. Shall we write same thing? B omega r square by 2. Actually, we'll do one thing. AO will OA will be write it AO. AO will be this much here. What about the OOD? Anybody please give it. This is a ring. I'm putting ring. Okay, integrate from R to 2R. Give me the value of OD. Somebody integrate. No, what is there? B omega by 2 R to 2R across OD is needed. No, the ring is rotating about A. Okay, this will become 4R square minus R square by 2. 3B omega R square by 4. It's asking OA. So there'll be one rod between this will come, and also there'll be between this particular thing. I think we have to draw a lot of equivalent circuits here. Between O, there's one cell, E potential, which will be B bar. This is for rod. And again, we'll get it. One more. Which one? This will be. This is for ring. EO symbol. I'll call this is E1. Easy for me to substitute. E2, E3. Okay, this is E1. This E2. And again, we have B bar velocity. So this will be. This is E3. This is point B, point D, O, and this is A. And A and D are connected, no? Because the ring. What we can do it total. EOA is asking. So even E3. So this E3 is how much we'll get it? E3. 3 BVR by 2. Is asking potential difference between points O and A. What shall I write? BVR by 2. That's all. Only potential difference across this is asking. That should be equal to how much? BVR by 2. If you ask about A and D, BVR by 2 plus 3 BVR by 2 will become BVR. About which point the potential that being asked here? R square by 2. Nobody helps in calculation. Huh? Teacher only should do all small calculations. Small integration I asked, nobody responded. R square by 2. Okay, this will become 4R square minus R square. Correct? No, this one. 3B omega R square by 4. So omega equal to V by R. Oh, rod is after integrating how much you'll get? Correct? No, for rod is correct only, no? For EOD, 3 BVR by 4, it is this one. Please unmute and talk. No chat, I'm unable to understand. Anybody wants to give suggestion, please unmute. Here. Some correction with this. Yeah, fine. Okay, 3 BVR by 2. This is EOD is what? We'll get it here. At this instant, okay, 3 BVR. Suppose if we ask something about point O and D, you have to write this much. OA, it should be BVR by 2. If you ask about these 2 points, you have to write 2 BVR. So I think this is what asked. I'll just go for it because E2 equal to E1. These 2 cells will be in parallel. So some tricky ideas, questions will be there of this kind. So that this will be our answer. Okay, we'll explore the next other types of questions. If there are 2 rings are there, of different area, they are moving with a speed 2v and 3v. This is having radius 4a. This is 2a, and there's a uniform magnetic field. I want potential difference between point P1, P2. There's a conducting surface. You have to find out potential difference between points P1 and P2. Find the potential difference between points P1 and P2. Okay, how to calculate? Both are conducting rings. Conducting surface, there's also iron ring with a copper ring. Just like a moving rod, no? It is. So what is the EMF induced? So this will be like a cell, B bar velocity. So this will be like a cell. Then that. So this will be B bar. There's a B bar. Okay, there's a B bar. So this will be like a cell. So just use motional EMF, B bar and velocity. So this P1 should be positive, this should be negative. So what about here P2? So regarding this will be polarity. So there's a point P1, P2. What is EMF induced? We can write it as, this will become B2V 4A. The EMF induced will be B3V 2A. It's a very popular problem. So net EMF induced from P1 to P2. So EP1, so I'll write VP1 minus 8 BVA minus 6 BVA minus VP2 equal to 0. Is equal to 14 BVA. Second, if the rings are having pure rolling, what you are going to do in that case? What all EMF will be induced only due to rotating motion. No? So let's do one thing. If I have a disk, I'll bring a disk. First, let me explain the concept here. I'll rotate this disk with an angular velocity omega. I want potential difference between its center of the disk to circumference. So there's iron disk. There's a uniform magnetic field is present everywhere. So what is the potential difference between center to circumference of the disk? So what I do is like, I can assume this particular disk made up of a rod, that's all. I'll find out EMF induced across this elemental rod. Then can I assume that this made up of such rods, I'll join them some 100 or 200, I'll get a disk. What is the EMF induced across this rod? This elemental rod. EMF induced across the rod. B omega A square by 2. B bar omega. So B bar omega. So this end is positive. This is negative. So what is the EMF induced for the disk? It should be same thing. Because you assume any number of rods, there'll be EMF induced. And how you're going to bring the cells? No, they're all they're parallel. What is EMF induced? What is the potential difference between points O and P? Should be equal to this one. Able to understand now? This is now. If I say that they're having pure rolling, then will there be any EMF induced due to rotating motion? Well, I just wanted to just discuss the small one. Okay, we'll do one thing. I'll bring a situation itself. Let me introduce all three situations. So there's a ring which is having a pure rolling, forward slipping, backward slipping, all three cases. And there's a uniform magnetic field is present in the region. Let the radius of the ring be R. This is V. This is omega. B omega. B omega. I'll first say, first case, I'll put it V equal to R omega, V greater than R omega, V less than R omega. Now, what's happening to this ring? No, this is a ring called iron ring. Anything will happen to its EMF induced across the ring. Due to transitive motion, I should take, due to transitive motion, it should come into picture. No? EMF induced between what points? I'm asking about these points. No, due to rotative motion, it should be zero, no? Because you can assume one more rod. Then if you assume two rods, what is the EMF induced? Suppose if this rod is rotating here in a magnetic field. How you give polarity? B bar, and the velocity, so this end is positive, this is negative. This is positive, negative. What is the net EMF induced from P1 to P2? Should be zero, no? Because we are going to write it in this way. So what all EMF will be induced only due to rotating motion will be zero, no? Between P1 and P2. Hope everyone is able to understand now. What is E is equal to, suppose if I put this is R. So due to rotating motion, the EMF will be induced will be zero across points P1 and P2. Only due to translative motion will come. So what is the EMF induced across both all three rings? Though they're having this is a pure rolling, forward slipping, backward slipping. What is the EMF induced in all these cases will be same. E P1 P2 equal to BV2R. for all three cases. Why there is no due to rotating motion? There'll be EMF induced between O and P1 and O and P2. The net P1 P2 will become zero. Any reason for that? I'm giving equation from here. In exams, you are going to get questions of this kind of application part. Nobody will ask you derive things. Let's take the all maximum. I am trying to discuss today the small idea based question. So there is a loop. There's a loop which is there inside the magnetic field. Now suddenly I'll pull it up. I'll pull it out of magnetic field. So there's a magnetic field is present. Then let R be the resistance of the loop. Let L be the side rest. Then how much of charge has flown through the loop? The loop is suddenly pulled out of magnetic field. Find the charge flown through it. Let R be the resistance of the ring of the loop. Let R be the now what you're going to do. So is there any flux linking the loop? Where is? Yes, there's a change in flux too. So and there'll be EMF induced, there'll be current will flow. Due to flow of current, there'll be flow of charge. Why charge will flow? Because flux linking the loop changes. Earlier, what is the flux? Initial flux is how much? BL square. Final flux is how much? Zero. Why zero? Because magnetic field is zero. The loop will have length and distance. Then nothing will happen to its parameters. Then flux linking the loop changes. So therefore, we'll write it here. EMF induced delta phi by delta t. Then what is the EMF induced? Due to induced EMF, there should be flow of current. What is the current? I is equal to charge flown delta Q by delta T. Okay, delta T get cancelled. So delta Q is equal to R into delta phi. Sorry, E equal to IR. I'll make changes. What is the change in flux? 0 minus. There should be negative sign will be there. So therefore, minus of 0 minus BL square by R. Very fundamental one. It's not a tricky problem, very fundamental. Like this, the change in flux and the charge flown are related. In the EMI chapter, these are the ways of asking question. You have to be very careful. I'm telling this one. As a teacher, we'll just share ideas. A student must have the overall application part. The questions can be very arbitrary from to any level. Any level means small ideas based questions should be there. Even sometimes as a teacher, no, we also feel little bit difficult. Like, okay, what is the idea involved? Now that concept is tough. That the idea has to flash for us. We'll go for the next condition. Even the rotation, even also if the loop is rotated, the same methodology is what we can discuss here. So let's go for the rail. It's a parabolic in shape. And we have a conducting rod on which it will slide. A thin conducting rod it is. Find EMF induced record. So there's a conducting rail, parabolic. Conducting rail. Okay, and this is a rod. So we have to calculate the EMF induced across it. Look at the rail. The rail is parabolic. It can be triangle. Already we have seen one triangle. It can be circle. It can be circular. So a different situations of this kind may arise for you. I'll do one thing. I'll make some. First, we'll calculate the EMF induced. There's a uniform magnetic field. If you want, I'll bring one problem itself. Huh? So let it slide with a constant acceleration A. Find the EMF induced. The rod slides with the constant acceleration A. Find the EMF induced across the rod. As a function of y. How you manage this? So there should be some resistance. Why don't you bring? Let R be the resistance. I think without that not possible. No. So let R be the resistance of the rod. He's asking only EMF induced. And EMF induced. He's not asking current. If you ask current, then we should go for resistance R. Am I right? And let's do one thing. What to do now? A different mathematical challenges, questions will come. You should be in a better position. Abhishek Nala, what you are doing here? No, parabolic. carry on the application part. What we do, so here I think the geometry, I'll bring into picture. Let me, the rod is moving, no? So let me go for the flux linking the, it will change. So this is dy, let this be x and x. So what is dA is equal to, I'll assume because the area of this loop will change, no? So therefore what we can write it is here, dy is equal to, so this will become dA is equal to 2x into dy. What is x? I can write it as root of y by k. Then the flux linking it, b into dA, dA equal to 2y by k dy. Y to power of 1 by 2 dy. Let me integrate this 0 to y. I'm just taking help of mathematics here. So this will become 2b under root k y to power of 3 by 2 by 3 by 2. 4b 3 root k. So it is accelerating with a constant acceleration. At t equals 0, it was here. At any time t, the rod is here. So therefore, what is y is equal to, you can write half at square. Questions will be very tricky. I'm telling this one. We have to take help of. Okay, in place of y, I should write a by 2 t square to the power of 3 by 2. Okay, this will become 4b a to power of 3 by 2. Okay, this will be. So now we'll differentiate this. This will be EMF induced across the rod. 4b a to power of 3 by 2. 2 square will be, I think only root 2 will come here. EMF induced across the rod will be, check one's calculation. Root 2 a to power of 3 by 2 b, 3 will get cancelled, root k t square. Replace t square again to y by a as a function of y is asked. Root 2 b a 3 by 2 under root k. T square is what? 2y by a. Let's simplify this further. No place. 2 root 2 b, this will become minus 1 by 2. So this will become only a. Check once.
Sir, a power 1 by 2.
A power 1 by 2. No, 3 by 2 minus 1 by 3. No, 3 to 1 by 2. Root 2. Okay, this will be root 2 ak. Okay, I think this should be our answer. I'll make it small, make observations. I think how we started, assuming what will be that the mathematics is very important. First we assumed a strip, then we proceeded here. Make observation. Just I'm typing some message to college. Meanwhile, you make observation. Yeah. So parabolic rod, circular rod, triangular shaped rod. So different things will come. So you should be ready for all different shaped the rails. Okay, fine. Okay, let's take the next condition. One problem. Suppose say if we have look at the loop. So this will lie in so this O, E, B, this is C. So there's a magnetic field is there, 2t square I cap 3t j cap plus tk cap. So the loop OAB lies in XZ plane. Then the OBOCB lies in YZ plane. And the radius of this, it's a semicircular arcs actually they are. Semicircular ring, one semicircular ring lies in the OA in the YZ plane, other will be in the OBC. Semicircular ring OAB lies in XZ plane and semicircular ring OCB lies in the YZ plane. So now I want the EMF induced. And the magnetic field is somewhere directed in XY plane in this way. Now, what you have to calculate, find EMF induced in the loop. how to manage this? There is a, say we need the area vector here. So get on to the mathematics of this one. Flux equal to B bar dot A bar. The A bar is what we have to define. B bar is already is there. 2t square I cap 3t j cap plus t k cap dot. What is A bar? A bar will become pi A square. Pi A square. So one loop will be j cap. Sorry, one will be I cap. The other will be j cap. Pi A square by 2, pi A square by 2. Make observation. There's only method available. Define area vector of this flow. Some segment lies in one plane, other segment plane. So define the area vector. Bring the area vector like this. So what is the area? What is the area of this one? Pi A square. I cap, no? What about the area of this? Pi A square j cap. Now take the dot product. Now then differentiate, you'll get the required answer. Hope, can you do this? The EMF induced in the loop will be. So these are the very small numericals of this kind, very important. Definitely anybody will be interested in asking such ideas. The use of this formula has to be brought into picture. Let me introduce to the next leg of problems. I'll go to the. Now there's some frame. Many were asking this one. I think you need some very good common sense. I don't think so any very big idea is needed. So there's a joint here. What this joint will do? Not possible. This. Set right. Just yeah, fine. Okay, not this thing. So here there's a joint. These two are joined here. So this is having resistance. This is side A, side length B. B bar varies with the time. And the resistance per unit length of this wire be lambda. Why that is? So there's a frame here, this one. So what I do is like, there are frames, are there, this is being twisted here. This wire is being twisted and connected to this one. So there'll be EMF induced in this. There'll be also EMF induced in this. So we have to find out the current. Find the current in the circuit or in the loops. Net current is what is being asked. Find the net current in the loop. So there'll be EMF induced. So if I put A greater than B, so there'll be EMF induced in the loop. So what is the EMF in the first loop? Equal to A square into B naught, because the magnetic field will vary with the time. Similarly, EMF induced in the second loop is B square into B naught. Since A greater than B, so E1 should be greater than E2. Who will determine the flow of current? This one. The left loop, the EMF induced in the left loop. So equivalent circuit will go for it. So the equivalent circuit will be, you have to draw again, there is no effort. By seeing, we want it. That's the major problem. So look at your teacher, how is going for a diagram, no? So after drawing this much, anybody can manage here. So this is E1, this E2. What is the resistance of this? Lambda A, lambda A, lambda A, lambda A, lambda B, lambda B, lambda B, lambda B. Now tell me like which will be greater, E1 greater than E2, will determine the flow of current. This cell will determine flow of current. So the net current here will be in this direction. Resultant current it is. So what is I is equal to? I is equal to E1 minus E2, 4 lambda A plus 4 lambda B. E1 is how much? B naught A square. B naught B square. 4 lambda A plus B. So B naught A minus B by 4 lambda. This is the expression for current. Let there be any number of loops and all. So you should know how to manage this one. That you have to make observation of joint. I think these are very popular. Check advanced paper, no? There are some 9 questions are there where student has to analyze here. Everyone knows formula. EMF induced equal to area into rate of change of flux. But these things is what you have to understand. Make observation. Will I had to start one more very important one. Say check-in app, we have plenty of other numericals in the revision program. I discussed them. If you get a time, no, so you can explore them also. So that in your revision, I'll bring some more new problems. If you say that, sir, what all there we have finished everything, means for your revision, I'll bring new problems. So for you, the number of numericals will increase, no? Now let's take the. So let's go for the next leg of concepts. I have a current carrying rod. Then I'll move a rod parallel to the length of it with a constant speed. So let this be A. This is L. This is a current carrying rod. So what is the EMF induced in the rod? PQ. So where the rod is moving, it is moving nearby long wire. No? And what is the type of field? It's a non-uniform field. So what is our method? I should go for a small elemental length. Let me choose elemental length. Okay, let this be at a distance x. This is dx. So what is the EMF induced? The EMF induced in the small element, let it be equal to D equal to dV dx. What is magnetic field at that point? Mu naught I 2 pi x. So here afterwards, if a rod is moving in a non-uniform magnetic field, what you are going to do? You are going to assume a small element. First EMF induced in that small element. Then you are going to integrate. Then what should be the limit? Limit should be from A to x is from A to A plus n. So the resultant EMF will be mu naught IV 2 pi log of A plus A by E. Will it behave like a cell? Yes, the rod will behave like a cell. Then put like a, what is the polarity? This end should be positive, this should be negative. So can I replace this with a cell? Yes, it'll behave like a cell. Okay, so then can I, instead of this rod, I'll keep it all the discussion here. Instead of this rod, can I, if I bring another loop or something, any changes will come. This will be a very important discussion for you. So I'll do one thing. I'll bring in some frame, square frame. Let me move this with a constant speed. Where this square frame, it is at a distance. I'm going to move this square frame with a constant speed v, such that its velocity is parallel to the long wire. Any EMF induced in it. Or what about the potential difference? I think so. We'll give number 1, 2, 3, 4. Okay, anything can be? I want answer from students. Will there be any EMF induced in the loop? One answer I got S, Meghana S. Okay, let's see. I want few more answers before I get into picture. Few more answers. Will there be any EMF induced in the loop? No, Gayatri, no, Meghana S. Any other? Boys from boys side, anybody? Yashovardhan, no. In fact, it should be no only, no, I feel. Srishta, no. Vinayak Nitesh, EMF will be induced, sir. So let's see that. Okay, what is EMF induced in the rod 1, 2? Yes, it will be there. It will be of this much. EMF induced in the rod 3, 4 will be that much. What about EMF induced in the rod 1, 4 and 2, 3? No EMF will be induced. So here I'll write it. E12 equal to E43. That's the same thing. What just now I derived, I'll bring it that one. That's all. No, we need now to just learn things. So what we are just now derived, no, there's a very fundamental. Oh, everyone, no, you should remember. See, like the exams you're writing demands you of this kind of preparation. The standard numericals, what all you learn, that data you must remember so that you can use that. Based on that, questions are coming. The advanced, why advanced is very difficult compared to other universities in the world means in other universities they just ask only basic fundamental. Here what happened, they'll ask on the applications of basic fundamental. Means some standard numericals are there, what the data will come based on that. So a student must be ready with all standard numericals and their information that you should know how to apply. I think this is what the overall preparation for advance one has to think about it. No, this is okay. Look at this one. EMF induced. What if EMF induced in the rod 1, 4 and 2, 3? I want answer from students again. EMF induced across the rod 1, 4 and 2, 3. Rod 1, 4 and 2, 3. How the velocity of the rod? It is parallel to the length of the rod, no? And we know motional EMF. No EMF will be induced in this rod and this rod. Will be zero. So then how do this will behave in this way? So definitely what you can say, no, net EMF induced equal to E12 plus E23 minus E43 plus E41. So this should be 0, no? Instead of all this, if you are very smart enough, you assume elemental structure here, elemental surface. What is the flux linking it? Will remain constant, no? As the loop moves, what happened to flux linking it? Remains constant. So finish home. No flux. The flux is constant, but rate of change of flux is 0. Flux linking the loop remains constant. That's why EMF induced. When the rod is here or here, what is the flux? Flux linking the loop is constant. That's all. So, or another reason, flux linking the loop remains constant. So therefore, d5 by dt is 0. The loop is in motion, but the flux linking the loop remains constant. Rate of change of flux is 0. That's all. We should not say no EMF induced in that rod, this rod. Yes, in some rod there are EMF induced. Can we say anything about potential? Yes, this is at higher potential, this is lower potential. What about these two? These two are at same potential. They are at same potential. This is at higher potential, this is lower potential. Sir, only this or any shaped loop? Let me go for the next one. Any shaped loop, sir? What all the discussion is there only for this one? So let me make it a general idea. So now the shape of the loop can be, where is this? Yeah. Anything, no? Or no, sir, I like ring very much. Okay, bring ring also. All these are moved with this constant speed. Now, what is EMF induced in all these three loops? E1, E2, E3, 0. They're moving their velocity that is parallel to the long current carrying wire. Any arbitrary shape it is. Okay, I think these are very fundamental. Sir, I'll connect one capacitor and resistor inside that. Connect it. Net EMF is 0, no? Just make observation of all. I think I'll introduce one more concept related to this. Let's take the let's have a there's a long wire and I'm going to move this with a constant speed V0. So let this be at a distance A now initially. Let L be the square length of this loop frame. Then what is the external force I should apply on the loop to move that with a constant speed V0? Find the external force applied on the loop to move it. Constant speed V naught. Perpendicular to the long wire as shown. What will be your again will 1, 2, 3, 4. Let lambda be the resistance of the resistance per unit length. Resistance of the loop. All mass, you can bring mass of the loop M. Side length is L and it is at a distance C. First of all, why we have to? Where the loop is moving now? It is moving in a non-uniform matrix. Shall we say here also EMF 0? Like previous case. Okay, you do one thing, just in a simple way, analyze the loop at two different portions. Let the loop be here. After some time will come in, area of the loop constant, but what is the magnetic field linking the loop? It's different. It's different. Magnetic field is different. So magnetic field is varying. So therefore, definitely there must be a flux linking the loop is in fact varying. So therefore, there will be an EMF induced. There will be induced current will flow due to flow of induced current. Then BL force will act. To oppose that BL force, I should bring an external force. So I'll start the analysis like this. So let me introduce a color. Let me introduce the elemental strip of width dx at a distance x. No, what is the flux linking it? Let it be d phi. There are many methods are there. D phi is equal to how you manage this. D phi is equal to B into dA. BA is equal to L into dx. So what is B is equal to? B will become equal to mu naught I 2 pi x L dx. What should be the limit? Limit should be from A to A plus L. This is a flux linking. Flux linking. The A is some parameter, no, which will vary. A is not a constant because as the loop moves, definitely this distance A will be varying. So therefore, the flux linking the loop is in fact varying. Let me differentiate this. D phi by dt. Mu naught IL 2 pi. Derivative of, okay, this will be log of 1 plus L by A. I'll write it. So this will become minus 1 by A square. dA by dt. Hope everyone is making observation, calculation part. Now this, we know EMF induced is minus d phi by dt. So this will become mu naught IL 2 pi A plus L. dA by dt is what? B. So this EMF induced in the loop. What action induced current will flow? Who will answer? Clockwise or anti-clockwise? Means 1 to 2 or 2 to 1 induced current. You better, I don't suggest you to take help of this. You go for Lenz's law. E bar into the plane. Then as the loop moves away, the flux linking the loop. Negative flux decreases, no? Negative flux decreases. d phi by dt positive, EMF induced negative. So therefore the current has to flow clockwise. Once again, I'm putting as the loop moves away, B bar linking the loop will decrease. Because as you move away from the wire, B bar should decrease. If B bar decreases, flux decreases. Negative flux decreases. D phi by dt positive, EMF induced negative. So the induced current has to flow clockwise. I suggest you don't depend on mass. Take help of Lenz's law. The induced current, in fact, will flow in this way. But what is our question asked? That external force, what external force we should apply it? So each arm now, each side of a loop is experiencing a force. How to get that I? So the resultant current I is given by I equal to E into lambda into 4A nu. Eight by lambda A square. 8 by lambda A square A into L. Okay, this is the expression for current. How do we can manage further? What about the force acting on 1, 4 and 2, 3? I say they are equal and opposite. Sir, how do? Because B bar, you put B bar. I'll draw a loop. Look at the forces that are acting on the various forces. B bar current, it will be you must come with all the ideas. I'm telling this one very, very, very essential. What all basics you learned, you should apply it. Now this B F12, in what action F12 will act? BIL force, B bar current. Okay, here B12 high L. This force will be B34 IL, which magnitude will be greater? BI1L2 or B34. B34 will be greater, no, because that is nearer to this force is near to this one. So the net BL force will act here. So in what direction the net action force should come in this direction. So this is 1, 2, 3, 4. I think things are very clear for you. So what is the external force? I should bring it here. External force should be equal to B1I2L minus, sorry, opposite to that, B34IL minus B12IL. What is I? I is this one. What is B34 minus just difference of magnitude? Mu naught I 2 pi. This will be at a distance of 1 by A. If you apply with this much of force, the loop will move with a constant speed. Next, whatever the power, yes, the power generated is what should be the power generated? F action into V naught, and what all that power generated should become I square R again. The same thing, because the loop is moved with a constant. Sir, if I just give velocity to the loop and release, anything will happen. It will undergo retardation and comes to rest. Similar to rod, but here the loop is moving in a non-uniform magnitude. That's all. Able to analyze the conditions. change in flux by time expression is IA square minus IA square. Oh, okay.
Sir, it is minus L square by L by A square, sir.
Oh, here one L is missing. I wrote it as a 1. Here L square. Okay, yeah. Thanks, Pranav. Okay. This is yeah, fine. All these are lengthy discussion type. Just only learn the method here. Huh? So this diagram is very important. You must really draw this. This is the most essential part of the problem, which will help you to easily get into the thing. Okay, let's take the next one. This having a resistance or not. This rails now having a resistance per unit length lambda. And the rod is initial at additions x naught. Or let it be at additions at t equals 0, the rod is nearby the resistance or not. There's the uniform man field. I'll move this with a constant speed v naught. Then I want expression for the current, everything. The rails are having resistance per unit length lambda. Can happen, no? The resistance of rails practically it can come into picture. So I'll introduce here at t equals 0, the rod PQ of mass m is at x equals 0. We'll put like this. It is moved with a constant speed v naught by an external agent. So, okay, there's a condition. Let lambda be the resistance per unit length of the rails. I'm bringing the rails will have a resistance. Let's not bother. We can manage very easily. Find the induced current and force, external force applied on the rod, and F external let's see what we can do. It's very simple. Moving rod will be like a cell, no? And at t equals 0, where the rod PQ is at distance x here. At any time t is what we are showing this one. So how the first the induced current. We'll keep this. We'll have one more diagram. What is the equivalent diagram you are going to have this one? These rails also will have resistance. It'll be much easier for you, no? The moving rod will be like a cell. There'll be a flow of current. Then external force is what is acting. BL force will come into picture. So what is first EMF induced? First will have EMF induced, which is equal to BLV naught. What is I is equal to E by resistance of rod R naught plus lambda X, no? 2 lambda x. Will agree this lambda x has to come here. Okay, this will become BL. So I'm telling this one, you can expect any of the changes, small changes in the basic things what we study. Check the advanced paper, he has just brought this idea. Many students struggled a lot. The reason for that, they were just happy with some set of numericals. Here I'll bring gravity, let mg will act, here friction will also come. The weight of the rod is m, no? Mg will be, so if I bring the gravity, then the normal contact will act here. So the weight will press the rod against the rails. So if I bring a friction is, friction force will come. So why don't you accept things like this here? Okay, then what is the external force? F external equal to BI. BL B square L square V naught by R naught plus 2 lambda x. Look at the force. You have to apply force of this kind. As x increases, Yashovardhan, I'm not understanding something.
Sir, it was my mistake, sir.
I'm not understanding. Like, L is the length of the rod. Okay. So the external force, what you should apply will be of this nature. If I drag with a constant force, then the problem will become F external minus BIL equal to MA. Then what is the equation for current will be of this. Then very good mathematics will come for you to enjoy. There's a practical one. What we have brought it, there's a very practical thing. So let me write here. Previous question also, yeah, it is A, no, you have equation A here. It will be in fact, yeah. The end equation, what you get, just look at that once and conclusion you make it. That'll be very useful. No, few more last. Suppose say there is a uniform magnetic field is there in a region. A very small problem. Just I'll take 2 minutes, then we'll wind up the class. Not Rangoli it is. I'll release a loop. This is a very important, even I feel like they can ask you. It's a very small concept, but learning that flux linking the loop all will be very easy for you. So suppose say this is the side length of the loop L. It is at a distance L initially. Let me take this is 3L. Then I'll release it. So let there be a gravity present. Absence of gravity or in the presence of gravity. Let M be the mass of the. I'll release it from rest. Loop is release it from rest. Then when it is entering this Mansfield region and when it is leaving the Mansfield region, what will be the direction of current and its magnitude? Only comparison. These are very popular. Something loop dragged into Mansfield, how the current will vary, different shape loops. Here I brought only square loop. Now what you should do after this, Asa, thank you very much. Then change this triangular loop, make it a ring, trapezoidal loop. Can do no? No, the moment it enters here, so first there won't be any. So different positions will indicate here. So first when it comes till here, no EMF induced. Increase the field. I'll increase the spacing. So it's very easy to indicate all other parameters. Now, very next moment, the loop will take this position. We will start entering. Then afterwards, it will be there fully inside. Then it will fully then come outside of the loop, no? Loop will not move horizontally. I have to explain. I just displaced it. Now, when it is entering here, flux, negative flux B bar will be negative, no? So negative flux increases d phi by dt. Negative EMF induced positive. So the induced current has to flow in this direction. No EMF will be induced. Any reason? Because flux linking the loop remains constant. So there won't be any induced current here. The moment again it starts leaving the magnetic field. Now the negative flux decreases, d phi by dt positive, EMF induced negative. So the induced current here will be in this clockwise. No. Check it, sir. How come current? They should be in same direction. No. Apply the lens law. According to lens law, the flux linking the loop. Yes, B bar is into the plane. Flux is negative. Or if you want, I'll write the phi 1 negative. So there's a position 1, I'll write it. Position 2. Phi 1 is negative. D phi 1 by dt is negative. EMF induced positive. What about phi 2 is negative. D phi 2 by dt is positive. EMF induced negative. Oh no, so we need not to bother anything. What about acceleration of the loop? The weight mg will act. What about the BL force? B bar, the BL force will act vertically up. And weight of the loop will act vertically down. And how the BL force? BL force what about here? The weight will act vertically down. Write it. Position 2, position 1. The weight will act vertically down. BIL force, how it will act? B bar current. So it will act vertically up only. In both the situations, how the BIL force will be acting. Net force on the loop it is. So this will be the acceleration. E2, this will be the acceleration, E1. So what do you expect E1 less than G, E2 less than G? Anything can you say about the current? Is anybody answers current equal or different, or I1 less than I2 or I2 greater than I2? I2 greater than I1. Three possibilities are there: equal, or both are zero. Net force on the loop should be zero. Whose side? When it is entering or leaving, there should be net force, no? Yashovardhan, please think on it. Only this part, this rod is outside the magnet field, will not experience force. Force experienced by these two rods, equal and opposite. Only this rod will experience force. Will be there? No. Now here the net force will be zero. Only weight will act. It will in fact accelerate here. Flux will be zero. And I'll give 3, 4, 5, 6. So EMF induced in 5, 3, 4, 6 is 0. Okay, there's a very small idea based problem. We have to analyze. We don't have any much. We know to fight with anything. Just only making analysis. What about current? Okay, we have brought everything fine. What about I2, I1? I'm waiting for your answer. It's already 10:10. We have to wind up the class. No answers. I2 should be greater than I1. Any reason? Because the loop here will be moving with more speed, no? Because it is in fact accelerating, no doubt. The loop is moving with more speed. This rod will have more speed than this. EMF induced will be more here than this one. So I2 must be greater than I1. Very important. And E2 will be greater than E1. Resistance of the loop is constant. Now, different shaped loops will enter or leave the magnet field. You should focus on numericals on these type also. I'll end up the class. Okay, we had like a discussion on the applications of motional EMF. So like this, I can keep on discuss the numericals. There's no end on numericals of this kind, what I feel. So try to take different numericals of applications. Still plenty are there in the tomorrow's class, if possible. If time permits, I'll discuss few more numericals on this one, the applications one. That will be useful for you for the advanced exam. Okay, after 10 minutes, we'll come back again. Okay, thank you all of you. Take care. Bye. See you.